So difference of two squares, we are saying, let's recall what we did last time and we put in our books. We said when you multiply this, now this is A and this is also A. This is B and this is also B. But the difference is on the sign. One sign is positive and one sign is negative. Please take note, if the signs are all the same, then that is not a difference of two squares. It will give you another identity. But here, the signs are different. This one is positive and this one is negative. But the other numbers are the same. So here we can clearly say that when we open brackets, this thing will give us a difference of two squares. Don't ask me where this is coming from. You agree with me that we did it last time. Check in your notes. We also expanded it, and this is what we got. Please go there and check. So we call that a plus b into a minus b is equal to a squared minus b squared. Now, that's the difference of two squares, the difference of the squares of two numbers, the difference of the squares of two numbers, difference of squares of two numbers. The first number is this, so the difference of square of A minus square of B. The difference of the squares of two numbers is equal to the product. Understand the English. The difference of the squares, this is my first number A, this is my second number B. So I'm saying the difference of the squares. Difference means subtraction. You agree with that? So the difference of the square of A and the square of B is equal to the product. Product means multiplication of their sum. So this is their sum, A plus B, and the difference and their difference. Their difference is A minus B. And my dear friends, that's what we call the difference of two squares. You must never forget that as long as you are still a student of chemistry. I mean of math, sorry. So when you have a square, the difference of the square of A and the square of B is equal to the product of their sum. Their sum is A plus B, and product means multiplication. So we put bracket and their difference. So now I want to remind you of something. Remember from our senior one knowledge, if I have 8 equal to 4 times 2, it means 4 and 2 are factors of 8. I repeat, if I have 8 equal to 4 times 2, it means 4 and 2 are factors of 8. So if this difference of two squares is equal to A plus B into A minus B, it means that A plus B and A minus B are factors of this difference of two squares. So when I tell you to factorize this, your answer is only this one. That's why I'm saying, therefore, the factors of A squared minus B squared, since when you have this difference of two squares, it is equal to A plus B times A minus B. It means that the factors of this are A plus B and A minus B. This is very, very important. So in order to factorize the difference of two squares, it is important to rewrite the expression so that the squares are clearly seen. It is important to rewrite the expression such that the squares are clearly seen. For example, a question says factorize Factorize means get factors out of what they have given you. Factorize. Get factors from what they have given you. So I'm saying factorize a squared minus 9b squared. So I want to follow this. It is important to rewrite the squares, to rewrite your expression such that the squares are clearly seen. So what can I do to show that to make sure that my squares in this expression are clearly seen? You see, a here is squared. 9 is not squared, but b is squared. So the only number that is not squared is 9. But we know 9, there is a number which can be multiplied 2 times to get 9. And that number is 3. So I can make this one a squared, then minus. Where there is 9, I'll put there 3 squared. And b squared. Such that all the numbers I have here are squared. What am I aiming at? I want to use a difference of 2 squares. I want to use a difference of 2 squares. So 3 squared, b squared, it is the same as 3b. I can put 3b, then I put the squared outside, because 3b times 3b, you are still going to get this. 3b times 3b, you are still going to get this one here. So I can put 3 in bracket and b in bracket, the way I have it. Then when I do that, I'm going to have my difference of 2 squares. So remember the definition. The difference of 2 squares of the difference of squares of 2 numbers is equal to the product of the sum of the numbers and their difference. It is equal to the product of the sum of the numbers and their difference. So what is the sum of these numbers? Remember our numbers that are squared, one of them is a and the other one is 3b. So their difference is a minus 3b, and their sum is a plus 3b. So the difference of 2 squares, when you have 2 squares and they are being subtracted, you have 2 squares and they are being subtracted, the answer you get will be the sum, the product of the sum of those 2 numbers and their difference. So finally, my factorized number is a squared, I mean a minus 3b into a plus 3b, meaning when you multiply or open bracket, you should be able to get this. So that's what it means to factorize. To factorize, it means to get factors out of what you have been given. Before I take you to another example, is there anyone who has a question on this? It is very important that you understand this, please. Is there any person who has a question about how we have factorized that? Feel free. Okay, so that means you are okay. Now here I give you another example. I have 1, we are factorizing 1. 1 minus 16x squared, and this is equal to 1 squared minus 4 squared x squared. Now listen, when you see 1 in a difference of 2 squares, 1 is always the same as 1 squared, because 1 squared is 1 times 1, which is still 1. So for us, even if we have not shown you that it is squared, Kate, stop writing on my screen. Remove your things. even if we have not shown you that it is 1 squared, for you, you have to create a difference of 2 squares. Remember what we agreed? We said it is important to rewrite the expression so that the squares are seen clearly. So if I have 1 minus 16x squared, I will call it 1 squared. Then where there is 16, remember, this one is now squared, even x is squared, but it is 16, which is not squared. Where there is 16, I will put there 4 squared, and it will become 1 squared minus 4 squared x squared. And 4 squared is 16, so I put it there, as you can see. So where there is 4x now, 4 squared x squared, I can put 4x in bracket such that the whole 4x is squared. The whole 4x is squared. So what does that mean? It means that when you get 4x times 4x, you are still going to get the same thing. But this is only possible when you are multiplying. This is only possible when you are multiplying. So finally, this one now becomes a difference of 2 squares. And what did we say? The difference of 2 squares is equal to the product of their sum. So the sum of the squares will be the sum of the numbers, making the squares will be 1 plus 4x, which is this. And the other one will be 1 minus 4x. The product of the sum of the numbers and their difference. So we have 1 minus 4x into 1 plus 4x. And I have another example here. We have 4x squared minus 25y squared. Now, you see everything is squared, x squared, y squared. So I will write 4 as 2 squared x squared, then 25. I write it as 5 squared y squared. Then I put 2x in bracket and square it. Then I put 5y in bracket and square it. And now this one also becomes a difference of 2 squares. So how will I deal with it? How will I deal with it? I go to the definition. The difference of squares of two numbers, the difference, the subtraction of squares of two numbers is equal to the product of their sum and their difference. So what is the product of their sum and their difference? Their sum is 2x. Their sum will be 2x plus 5y, and their subtraction will be, their difference will be 2x minus 5y. So this is what we end up with. I again ask, is there anyone with a question?
I have not understood.
Where? Don't say you have not understood and go away. Where haven't you understood?
Yeah, part C.
Part C. Okay. Part C, let me repeat it again. Pay attention. Now, we are saying, when you look at this, you should aim at creating a difference of 2 squares. A difference of 2 squares means you have two numbers and they are all squared, but you are subtracting them. That's what it means. Difference of 2 squares. You have two numbers which are all squared, but you are subtracting them. And we said what you get should be the product of the sum. Product means multiplication. So you multiply the sum of the two numbers which are squared and their difference. So this one is 4x squared. I want to create a squared. Now to create squared on 4, it becomes 2 to power 2. and to create squared on 25, it becomes 5 to the power 2 or 5 squared. Eh? That's why I said let it be 2 squared, because 2 squared is 4, x squared. Then this one will be 5 squared, y squared, eh? Because 25 is 5 squared. Now when I do that, since the 2 is to power 2, x is also to power 2. In primary, you studied some indices. You agree with me that 2x to power 2 is equal to this one. They are the same. And 5y to power 2 is equal to this one. They are the same. Why am I doing it like that? I want to create the difference of 2 squares. I want to create the difference of 2 squares such that this number is squared and this number is also squared. So when I achieve that, what does that mean? The difference of 2 squares, when you have these two numbers, they are squared and you are subtracting them, the answer you get is the multiplication of their sum. Their sum is 2x plus 5y, and their difference is 2x minus 5y. I think it is now clear for you, Ethan.
Yes, teacher.
Any other? Now let us look at this. We are saying, however, some expressions which involve the difference of 2 squares require us to find the common factor. The common factor. For example, if you look at this is 7x squared minus 7y squared. When you look at this, you realize that on this term there is 7x, and also on this term there is 7x. I mean there is 7. Okay, on this term there is 7, and on this term there is also 7. So that's what we mean. So 7 is a common factor. 7 is a common what? Factor. So if 7 is a common factor, what do? We factorize it out. So both terms contain a common factor, which is 7. Therefore, we first factorize 7 outside the bracket. We open bracket and pull out 7. It is here and it is also here. So this one becomes 7 into, this is x squared minus y squared. When I put out 7 here, I remain with x squared. When I put out 7, I remain with y squared. And you see, this one is exactly equal to that. So that's what we mean by factorization. When you see a term that is here and it is also here, you bring it outside the bracket. Or a term that can be divided here and it can also be divided there, you bring it outside the bracket. So when I bring 7 outside the bracket, what I remain with in bracket is now a difference of 2 squares. And the numbers that are squared are x and y, and I'm subtracting them. So the answer is going to be, their sum is x plus y. We multiply by their difference, which is x minus y. I have another example here. Now, when you look at this example, this is 3 and this is 75. Now, in this first part, 3 is a factor. In other words, it can be divided here. A factor means a number which is divisible in there. When you look at this, 3 is also a factor. It can be divided by 75 and it gives you 25. So what will I do? I will put out 3, since it is a common factor. I bring it outside the bracket and it gives me 3 into x squared minus 25. Because 75 divided by 3, the answer is 25 minus 25y squared. Before you proceed, first check out, ensure that when you open bracket again, you will get what you had at first. So 3 times x squared, it is 3x squared. Then 3 times 25y squared, it is 75y squared. So that means that I have factorized very well. That's what it means. So from there, what should I do? I will create a difference of two squares. This is x squared. This is 5. This is 5 squared for 25, and this is y squared. So I will say this is x squared minus 5 squared y squared, which is, I can put 5y into bracket, and as you can see, so this one will be 3 times a difference of two squares here. And the squares are, the numbers which are squared are x and 5y. So the answer will be, don't forget this 3, it will be 3 into the difference, the multiple of the difference and the sum of the numbers. The difference is x minus 5y, and the sum is x plus 5y. So the difference of two squares, don't forget, if you have two numbers which are squared, the answer you get is the sum of the numbers multiplied by the difference of the numbers. Now, any question before we proceed? So let me take you to these more examples. Now, in these more examples, here I don't have unknowns. I can have just digits. So in this one, I have 99 squared minus 1. But when you see this one is squared and this is minus and this is 1, remember 1 is the same as 1 squared. Eh? So 1 times 1 is also 1 squared, and which is 1. So that means I can say this is 99 squared minus 1 squared, and this becomes a difference of two squares. What do we do with the difference of two squares? It is the same as the product or the multiplication of the sum of the two numbers. The sum of the two numbers is 99 plus 1, and the difference of the two numbers is 99 minus 1. And the answer will be 98 times 100. 99 plus 1 is 100. And the calculator will give us 9800. If we look at this one also, part B, we are going to have, this is also 8.49 squared minus 1.51 squared. So that means I will have 8.49 minus 1.51. So this is the difference of two squares, and the answer will always be the multiplication of the addition of the sum of the numbers, or addition and their difference. So the sum of the numbers is 8.49 plus 1.51, and the difference is 8.49 minus 1.51. This is the difference and this is the sum. So finally we get 6.98. If you have a calculator there, confirm this. 8.49 minus 1.51. Does it give you 6.98 times this one? The answer is 10. So finally, Our answer is 69.8. So this is the assignment. Today I've given you some good numbers, but by one you'll be done, because it is just a matter of using a difference of two squares. Use a difference of two squares everywhere. But remember, if there is a common factor, like here, 375, first bring out the common factor. Let me hope you understood this example. Common factor, you mean a number is divided here, and it is also divisible here. So you bring it outside the bracket. You don't divide, but you bring it outside the bracket, such that when you open the bracket, you'll get the same thing that you had at first. So that is called factorization. In other words, I have factorized out 3 outside the bracket. I say the mathematical statement, I say I have factorized out 3. Factorize out 3 from here. So when I remove 3, I remain with x squared. And when I divide by 3, I remain with 25 squared. But when you open the bracket, you'll get the same thing. So that is what is called factorization. Hope you have understood that example.
Yes.
So,
Yes, teacher.